Let's calculate the formal charge on each atom of carbonyl chloride. To calculate the formal charge, we need to know the Lewis structure. The formula to calculate the formal charge is number of valence electrons minus number of lone pairs of electrons minus number of bonding electrons by 2. Now, we know that oxygen is more electronegative than carbon and chlorine is also more electronegative than carbon. Therefore, we are placing the carbon atom at the center and then placing the electronegative atoms around carbon. The atomic number of carbon is 6. Therefore, the electronic configuration is 1s2, 2s2, 2p2. Here we have 4 valence electrons. Atomic number of oxygen is 8. Therefore, the electronic configuration is 1s2, 2s2, 2p4. Here we have 6 valence electrons. Atomic number of chlorine is 17. Therefore, we can write the electronic configuration this way: neon, that has 10 electrons, and then 3s2, 3p5. Here we have 7 valence electrons. Now, let's place the valence electrons around each atom. We have 4 valence electrons for carbon. Therefore, let's place the valence electrons around carbon. Let's place the 6 valence electrons around oxygen. 1, 2, 3 as 3 lone pairs. And then let's put the 7 valence electrons of chlorine on both sides. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This makes 1 bond pair. We can make 2 bond pairs with these 4 electrons, and we can make 1 bond with these 2 electrons. Therefore, we can draw the structure this way: carbon and then 2 bonds, oxygen, and then 2 lone pairs, and then chlorine, and then remaining 6 electrons, that means 3 lone pairs. On this side also chlorine, and then 6 electrons, 3 lone pairs. Now, this is the Lewis structure for carbonyl chloride. We need to verify whether each atom satisfies the octet configuration. So, if you take oxygen, we have 2 lone pairs, 2 bond pairs, total 8 electrons we have. For carbon, we have 4 bonds. That means carbon also satisfies the octet configuration. For chlorine, we have 3 lone pairs, that means 6 electrons, 1 bond pair, 2 electrons. Therefore, chlorine atom also satisfies the octet configuration. Now, let us calculate the formal charge on each atom, because now we know the exact number of valence electrons, lone pairs of electrons, and bond pairs of electrons. Formal charge for carbon is equal to number of valence electrons is 4 minus, we don't have any lone pairs of electrons, therefore here it is 0, minus we have 4 bond pairs, that means 8 electrons by 2, therefore this is 4 minus 4, that is equal to 0. Formal charge of oxygen is equal to, we have 6 valence electrons in oxygen, we have 2 lone pairs, that means 4 here, minus we have 2 bond pairs, that means 4 by 2 here. Therefore, this is equal to 2 minus 2, that is equal to 0. Formal charge of chlorine, for both the chlorine atoms it would be the same. Therefore, this is equal to, we have 7 valence electrons in chlorine, minus we have 3 lone pairs, that means 6 here, minus we have only 1 bond between carbon and chlorine, therefore 2 by 2. Therefore, this is 1 minus 1, that is equal to 0. Therefore, the formal charge of each atom in carbonyl chloride is 0.